Assalamualaikum warahmatullahi wabarakatuh, and a very good day to our panels. My name is Muhammad Izzat Farhan. I'm from Department of Chassis and Body. So today, my department would like to present our project, which is wheelbarrow. Before I begin this presentation, I would like to introduce each of our members in this department. In this department, there are 5 members including myself. First, I'm as a head of department, and then we have Muhammad Aziz Ahnaf bin Muhammad Khalid. He is a design engineer. Next, Muhammad Azmel Adli. He is a test engineer. Next, Nur Anisah binti Muhammad Kamal. She is a quality engineer. And lastly, Nur Farah Najwa. She is a R&D engineer. Next, I will explain each of our members' job scope. So first, myself, I'm a project engineer for this project. So my task is assign responsibility and mentor project team members. Besides, I'm also manage quality control of work such as budget, schedule, plans and personal performance. Next, Muhammad Aziz Ahnaf. His task is to create final design of the product by using CATIA. He also research and draft blueprint, engineering plans and graphics. Next, Muhammad Azmel Adli. His task is to perform engineering analysis. He also analyze test results, detect issues and track root cause. Then Nur Anisah Muhammad Kamal. Her task is to improve product quality by recommendation for change. She also ensure that product follow the quality standard. And lastly, Nur Farah Najwa. Her job is to perform market research on the product. She also manage product development and production. So that's all about the introduction to our members. We will proceed to the next presenter.
This is our Gantt chart. Basically, before we proceed to our project, we do the planning and scheduling our project so that we're able to complete all the tasks on the right estimate time given. As we can see that the orange one refer to planned work period and the yellow one refer to our actual work period. Even though our actual work period is slightly different from our planning, but however at the end of our study, we're able to manage and complete our project on the right time. From this slide, it shows us the survey results. Before we proceed to do our project, we did the customer survey by using the Google Form as our platform. And about 31 respondents respond to our survey. And based on the survey, we tried to analyze and identify what the customer demands, what the problems that customer had faced on the current wheelbarrow on the market nowadays. So, by identifying all those problems and what the customer demands, it helps us a lot for us to design the wheelbarrow for our project. Scope and project value, the problem statement, it is based on the customer survey that we had done, and also we did the market research on the existing wheelbarrow, and from that we found out that there are several problems on the existing wheelbarrow. Firstly, non-ergonomic wheelbarrow. As we can see that most of the wheelbarrow on the market nowadays, it requires the user to bend the back to up the handle to carry the load. This posture will lead to the back pain to the users. And secondly, complexity in design. The more complex the design, the more cost required to maintain the maintenance. And some complex design will lead to the confusion towards the users to use. And lastly, low durability and reliability of the design, where the wheelbarrow is not able to sustain the heavy load and the lifespan of the wheelbarrow cannot last long. And next, the customer expectation. Firstly, high durability, where the wheelbarrow able to sustain the heavy load. Secondly, large capacity. In our project, we are focusing on the construction field, so it required a large capacity to carry the load on the construction field. And thirdly, high safety, where the wheelbarrow is safe to use. And lastly, great stabilization, especially when we're carrying the load on the uneven surface. Next, our project goals. Firstly, we want to achieve a high reliability and durability of the design, where our design able to sustain the heavy load, and at the same time, the design of our wheelbarrow able to last long. Secondly, to increase the health and safety to the users, especially to have a good posture while carrying the load, so that there is no need for the users to bend their back that will cause the back pain. And lastly, to able sustain a heavy load, where our wheelbarrow able to sustain the load up to 100 kg. Next, we proceed to the task in order for us to completing our project. Firstly, to do some research about the suitable materials that can be used in order for us to serve a high quality material for the design. And at the same time, we're able to identify whether the material that we use will create the negative impact towards the environmental or not. Secondly, to do market research on the existing wheelbarrow. It is very important for us to do some modification on the existing wheelbarrow. And thirdly, to design the product. And next, to do research on the user-friendly mode, especially at the ergonomic handle part. And lastly, to calculate all the costing for the product. Either our product is on the budget or out of the budget, so that it is affordable to the customer to afford it. In deliverables, as our project, we are focusing on the construction field, so we designed the wheelbarrow to have the large capacity of load. Secondly, the wheelbarrow also have a high stabilization, so it is easy for the user to use the wheelbarrow on the even surface and also on the uneven surface. And thirdly, the wheelbarrow also designed to have a ergonomic design, where it more towards the user friendly. And lastly, the maintenance cost for the wheelbarrow is low. Then we proceed to contingency plan. There are several problems that we had to face in order for us to complete the task. Firstly, the problems on using solid for frame entry. And then we had a meeting to discuss on solution to solve the problems. And then we decided to change the solid to hollow. The one who responsible for this task are Izzat and Hazmi Adli. The second problem is rejected method on balance sheet analysis. And then we refer to the lecturer on the method to analysis and calculate the balance sheet. And then we reanalyze the balance sheet. Hazi and Izzat are the one who responsible for this task. And lastly, the rejected method on the calculation of the tree. And then we had the meeting to discuss on what the new formula that we need to use to calculate the tree. And then we found out the new method to calculate the tree. And Anissa and I are the one who responsible for this task.
Next is our project costing. In this part, I will show our product cost estimation. First, we have a direct costing. For direct costing is a cost that we have spent for raw material of the product. Raw material that includes stainless steel sheet, hollow mild steel, stainless steel rod, and mild steel pipe. And then we have a specification of each raw materials, and then quantity that we use, and total for raw material is RM386.30. Next is indirect costing. For indirect costing, we have calculate for electricity and machining, and then we have a specification of task, and total cost for indirect costing is 180 ringgit. Next is a balance sheet. This is our balance sheet for Department of Body and Chassis. So for this balance sheet, we have calculated the total current assets and also total current liabilities. So total asset is 2,300 ringgit and 80 cent, and total liabilities and equity also same, which is 2,306 ringgit and 80 cents. So that's all for project costing.
For the development of our product, we use House of Quality, where it can help us to identify what the customer wants and show the quality of our product. In order to make a House of Quality, we need to know and list all the customer requirements that are relevant to the product. So in order to know what the customer wants and all the requirements, we had conducted a survey, and based on the survey, we have all the criteria that need to be evaluated by House of Quality. We also use morphological chart for our product development, where it can help us to generate and come up with a few ideas for our concept design. So we had circled the best concept for each component, such as material of the frame, material of the tray, types of tire, types of handle, shape of the tray. So by the end of the chart, we had obtained 3 types of design. After we obtained the 3 design from the morphological chart, we use path chart to evaluate each of the design. So from the path chart, we can see that design number 2 has the highest net score, which we should proceed with design number 2. From the path chart, we can see that there are some criteria that contribute to the high net score of design number 2 are safety, durability, complexity, weight, and maintenance.
Assalamualaikum. Today I will be presenting on the engineering blueprint. Engineering blueprint is a type of part drawing which consists of dimension, the side of view, which consists of top, front and side view. In this engineering drawing, we'll also have the dimension, which will be used to make the product itself from scratch. This is the pillow material, which consists of 3 parts, which is the tray that will be used to place the object that we'll be carrying, and the frame, which will be the support to move the object that we'll be carrying. As for the third one is the rod, which will be used as a connector of the tray and the frame, which will combine it with a simple mechanism to be in one object. So the tray itself will be labeled as TR1, which contains 1 quantity. As for the frame, it will be labeled as FR1, which also has a 1 quantity, and the rod itself also labeled as RD1, which will be also 1 quantity. Okay, for the next part is the isometric view. This is the view that we'll be seeing for the object in our department, which consists of the tray, frame and the rod itself. Okay, for the next is the exploded view. As you can see, this is an exploded view, which consists of the 3 parts itself. Okay. And the next is the dimension part drawing of the tray. The part drawing consists of the dimension, which the length of the tray is 930 millimeters and the width is the 645 millimeters. As for the height is 340, and the inside length is the 844.72 millimeters. Okay, for the next one is the frame. The frame itself has 840 in length and about 750 in width. The handle itself has a height of 599, which also includes 35 degrees of angle. For the next one is the rod. The rod for the connecting the tray and the frame, which has a 10 mm diameter with a long of 750 mm. That's all for the engineering blueprint. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azmin Adli bin Muhaidi. We will continue on final design specification, or commonly known as PDS. Based on our department, which is body and chassis department, we are focusing on designing 2 points, which is the wheelbarrow body frame and the tray. The first is the wheelbarrow. The area of the wheelbarrow is 0.62 meter square and the handle height is 0.62 meter. The weight of the body frame is 10.9 kg. The construction type that has been used is 3, which is cutting, welding and grinding. For the cutting, we cut the steel into a desired dimension and then we will join them by using the arc welding, and then lastly we will use grinding to ensure the smoothness of the surface. The material that has been used for the handle and the body frame is stainless steel sheet for the cover of the base, square hollow mild steel for the frame of the base, and the mild steel pipe for the handle. The safety requirement that has been taken into the account when designing the body frame is tight handle grip and the ergonomic. Ergonomic will prevent the occurrence of the spinal cord injuries to the user, and for the tight handle grip will ensure the good handling while using it and prevent from injury such as blister. Next is the tray. The weight of the tray is 15.5 kg. We use the same type as the body frame for the construction type, which is cutting, welding and the grinding. For the material, we use stainless steel sheet for the cover of the tray and the square hollow mild steel for the frame of the tray. The safety requirement is smooth edge. Smooth edge will avoid injury to the user. This is because if there are sharp corner in each corner, it will cause injury such as tear if there any contact friction on the limbs. Next, we will continue on the engineering analysis. There are 4 type analysis that have been conducted on the each part of our design. The first is the body frame, second is for the tray, third for the tray, and the fourth is for the base of the body frame. Okay, the first analysis is on the body frame analysis, which is conducted on the statistical analysis and the calculation based on shear force and bending moment diagram. Based on the statistical analysis, von Mises stress distribution, we can see there are 3 color scattering on the surface, which is blue, turquoise and green. The green is the highest stress occurs on the base of the frame, which is 2.7 exponent plus 0.05 Newton per meter square. The young modulus is 2 exponent plus 0.11 Newton per meter square. The Poisson ratio is 0.266. The density is 7,860 kg per meter cube, and the yield strength is 2.5 exponent plus 0.08 Newton per meter square. For the calculation based on shear and bending moment diagram, first based on the distributed force, we calculate the point force at the center. Then we calculate the reaction force at the end of the steel, which is RB and RA. The value of RB and RA is 735 and 75 Newton. Based on the value, we transfer the value to the shear force diagram, as we can see here, and then after that we transfer the value to the bending moment diagram to calculate the maximum stress occurs at the center of the base, so that from the calculation we can get that the stress occurs at the center is 1.4 megapascal. As the stress is lower to the allowable stress, hence the design is safe when 100 kg load is applied on the surface of the body frame. Next, we're conducting the analysis on the tray. We're conducting the statical analysis on the CATIA, which is volume versus stress analysis. As we can see on the front part of the tray, the red color represent the highest stress, which is 2.4 exponent plus 0.05 Newton per meter square. The young modulus of the tray is 2 exponent plus 0.01 Newton per meter square. The Poisson ratio is 0.266. The density is 7,860 kg per meter cube, and the yield strength is 2.5 exponent plus 0.08 Newton per meter square. Next, we calculate the volume capacity of the tray. We divide it into two sections and add up the calculation, so that we obtain that the volume capacity is 230.69 liter. So that if we fill any brick or cement, it can fill and up to 230.69 liter. Okay, the next calculation for the tray is we calculate the size of hole of the hinge to insert the rod. First, we calculate the reaction force act on the hinge, which is Rx and Ry. Rs equal to 17.32 kN and the Ry is 8.77 kN. Then we total up the reaction force acting on the hinge, which is 19.41 times 10 to the power of 10 power of 3 Newton. Next, from the factor of safety equation, we can obtain the area, which is 84.39 mm square. Then from the area formula we can obtain the radius, which is 5 mm. The 5 mm is the radius that very suitable for the hinge in the tray. Next is welding analysis. The welding analysis is done on the T-joint of the base frame with 5 mm throat and 30 mm length. The objective of the analysis is to determine the shear strength of the welding and the factor of safety, and it can withstand the load or not. Okay, the force acting on it is 981 Newton. We use a ISI 1018 my steel with the yield strength 370 megapascal. Based on the Shigree textbook from table 9.2, we find the area, which is 2.121 times 10 to the power negative 4 meter square, and we find the I, which moment of inertia, is 4.77 times 10 to the power of negative 8 meter to the power of 4. Then we find the primary shear. The primary shear is 4.63 megapascal and secondary shear is 106.43 megapascal. Then we find the maximum shear by combining the primary and secondary shear. We get 106.53 megapascal. And lastly, we find the factor of safety by dividing the yield strength with the maximum shear. We get 3.47, as 3.7 is higher than 3.0, so that the weld is strong enough. That's all from me. Thank you.